All right, hello and welcome. We'll be solving the above question under reinforced cement concrete. All right, now the question says a vertical flagstaff standing 10 meters above the ground is of square section. Note square section throughout, the dimensions being 100 millimeter times 100 millimeter at the top tapering. All right, 100 millimeter times 100 millimeter at the top tapering. Take note of all of this. All right, and what 200 millimeter times 200 millimeter at what, at the bottom tapering, at the ground or the bottom tapering, whether I say ground or the bottom tapering. Now we have a horizontal pull of 50 kilonewton. All right, it's applied at the top. The direction of the loading being along a diagonal of the section, we are asked to find the maximum stress, all right, due to bending. The maximum stress due to bending. All right, now look at this being very well. We were given y to be equal to what? A all over what? The square root of 2. The total length of this beam is what? Is 10 meter. All right, we are asked to consider a section. We are going to be taking moment, but not now. We have a section xx. All right, so all right, if you have been following our videos, you will know that we are going to take moment. All right, we also have the it is called the top tapering, which is what, 100 millimeter by 100 millimeter, and the bottom tapering or the ground tapering, as stated in the question, to be 200 millimeter. Now we are asked to find the maximum stress due to what? Due to bending. All right, now if you look at this beam very well, we first thing we are going to be looking for is the length of what? Of side at any section. All right, this is a diagonal section. The length of the side is what? A millimeter, A millimeter, A millimeter, and A millimeter. All right, so you are going to be looking for the length of side at any section A, and the formula for the length of side at any section of what? A diagonal square section is nothing but what? A equals to the top side plus the change in side all over the total height multiplied by x. All right, so we have A to be equals to what? The top side, all right, multiplied by what? The change in side. This is plus change in size all over what? All over total length multiply by x. This is what we have. This is change in side, not size. All right, this is change in side. All right, now the top side, as stated in the question, is 100 millimeter. So A will be equals to 100. All right, A equals to 100 plus the change inside is nothing but what? 200 minus what? Minus 100. All right, all over the total length, which is 10, multiplied by what? Multiply by x. So this is what we have. Now 200 minus 100 is what? Is 100. So we have A to be equals to 100, all right, plus what? Plus 100 divided by what? By 10 multiply by x. So 100 divided by 10 is what? Is 10. So A will be equals to 100 plus 10x. All right, this is in millimeters. Don't forget, all our values are in millimeters. Good. Now this is our value for A. Let me just put it down here, millimeter. All right, take note of our value for A. All right, now bending occurs along the diagonal of what? Of the square. All right, bending occurs across the diagonal of the square, and we know that the formula for diagonal of a square is nothing but what? D equals to what? A multiplied by the square root of 2, where A is what? Is the length of the side at any section. Take note of all of this. All right, so we have diagonal of square all right, D is equals to what? A multiplied by the root of what? Of 2. All right, so we know that A is what? A is 100 plus 10x millimeters. All right, so our D will be equals to what? Our D will be equals to the square root of 2 all right, multiply by the square root of 2 multiplied by the bracket of 100 plus 10x, all right. This is what we have, close bracket, in millimeters. So this is what we have as the diagonal of what? Of square. Now from the question, we're given the distance from the neutral axis to the top of the section, which is y equals to a all over square root of 2. All right, so y is equals to a, all right, all over the square root of what? Of 2. This will be equals to, a is nothing but what? A is nothing but 100 plus 10x millimeters, all right. So a will be equals to 100 plus 10 what? X. This is all over the square root of what? Of 2. All right, so this is what we have. All right, this is what we have. So we have a value for a, we have a value for d, we have a value for y. Actually, we don't even need this value for d that much. We need the value for y. Is very important. Next, we are going to be looking at the bending moment of this section. All right, look at this section very well. We have a section xx at a distance of what? X from the free end. All right, if we take the bending moment about this section xx, it will be nothing but what? 50 multiplied by x. Don't forget, bending moment is nothing but force times perpendicular distance. All right, this is the force and this is the perpendicular distance to the section where moment is being taken. All right, so bending moment, all right, will be equals to force times perpendicular distance. All right, it's equals to force times perpendicular distance, and we are going to will be equal to force, which is 50, all right, multiply by x. All right, it will be 50 multiplied by x. All right, now note we're given 50 newton. This will be supposed to be 50 newton, so just strike this kilo out, take note of that. This is 50 newton. All right, now I'm multiplying it by x, and all our units are, our unit here is in meter. All right, our unit here is in meter, so we need to convert meter to millimeter. All right, initially what we have here is nothing but what? Newton meter. All right, this is exactly what we have. Our x is in meter, our 50 is in newton. All right, now I want to convert this to millimeters, so I will multiply by 10 to the power of 3. All right, so our bending moment will be equals to 50 x, all right, times 10 to the power of 3 newton millimeters. This is what I have. All right, this is what I have. So now we can proceed to calculate further. All right, now let's proceed. All right, if you look at this section, all right, we have a square cross section, and the moment of inertia for a for a square cross section about the diagonal, I is nothing but what? A to the power of 4 all over what? All over 12, where a, don't forget, is the length of side at any section. All right, this is a very peculiar example. All right, so I is equal to a to the power of 4 all over 12. All right, so our moment of inertia of the square cross section about the diagonal is nothing but what? A to the power of 4 all over what? All over 12. Now this will be equals to, our value for a is nothing but 100 plus what? Plus 10x. All right, so we have 100 plus 10x all to the power of 4 all over what? All over 12. All right, so this is what we have. Now from what we have on the board, you can see that we have the value for I, we have the value for bending moment m, and we have the value for what? For y. So we are going to recall our formula for what? Theory of bending, or from our bending stresses in the beam. All right, we know that m over I is equals to what? Is equals to sigma all over what? Y. All right, so recall that m all over what? I is equals to sigma all over y. All right, so here we can make sigma the subject. If we make sigma the subject, sigma will be equals to m dot y all over what? All over I. All right, so this is what we have. All right, so we can now solve properly. we can now solve properly. This is where we are going to substitute and start solving. All right, sigma there now will be the maximum stress due to bending. All right, maximum stress due to bending. So let's continue from here, then we'll make use of this place before we go over to that place. So we have sigma. All right, we can say sigma max. All right, or we'll leave it as sigma for now, equal to, now I have m. My moment is nothing but what, 50x multiplied by 10 to the power of what, of 3. All right, so I will substitute my moment. So I have 50 times 10 to the power 3 x. What next do I have? I have y to be 100 plus 10x all over what, square root of 2. All right, so this is multiplication. I have 100 plus 10x, all right, all over what, all over the root of what, of 2. All right, everything is all over I is nothing but what, 100 plus 10x all to the power of 4 all over 12. So we have 100 plus 10x all to the power of 4 all over what, all over 12. Now this is what we have. If we rearrange this, it is nothing but what we have here multiplied by what, 12 all over what, all over this. So let's do that here. So we have sigma to be equals to, this is nothing but 50, all right, multiplied by 10 to the power of 3x multiplied by 100, all right, plus 10x, all right, 100 plus 10x multiplied by 12. Yes, this is 100 plus 10x, all right, multiplied by 12 all over, I now have the root of 2, all right, multiplied by the bracket of 100 plus 10x close bracket all to the power of 4. Yes, this is absolutely correct. All right, so you agree with me that 100 plus 10x, the bracket of 100 plus 10x, we cancel out one of these brackets here. I will left with what I have here to the power of 3. All right, so this is gone. All right, now 12 multiplied by 50 is nothing but what, 600. All right, so sigma will be equals to 600, all right, times 10 to the power of 3x. This will be all over the square root of 2 multiplied by 100 plus 10x to power 3. All right, so this is what I have. Now 600, all right, 600 is the same thing as 60 multiplied by 10. Now 600 is the same thing as 60 multiplied by 10. All right, so we say sigma will be equals to 60 multiplied by 10, all right, multiply by 10 to the power of 3x all over what, the square root of 2 into 100 plus 10x all to the power of 3. Now look at what we have here very well. We have 10 to the power of 1, and we have 10 to the power of 3. From our indices, this is nothing but what, 10 to the power of what, of 4. All right, now we have the bracket of 100 plus 10 to the power of x all to the power of 3. We can decide to bring it here. It will be nothing but what, the bracket of 100 plus 10 to the power of x close bracket all to the power of what, minus 3. All right, take note of this. This is our basic law of mathematics. All right, so we have sigma to be equals to 60, all right, times 10 to the power of 4 now. All right, we have x multiplied by, I have the bracket of 100 plus 10x close bracket to the power of what, minus 3. All right, we have all over the square root of what, of 2. All right, so this is what we have. All right, now we have this as this will be our sigma max. All right, this will be our, so this is what we have. All right, so take note of this equation. We'll call this our sigma max equation is equals to 60, all right, multiplied by 10 to the power of 4x, all right, into 100 plus 10x, all right, close bracket, all to the power of minus 3, all right, all over root 2. So take note of this equation. We are going to be coming back to it. For now, we have to find the value of what? Of x, all right? We have to find the maximum stress due to bending. Now, we know that the maximum stress due to bending will occur when what? Sigma, no, when the change in stress all over what? The change in stress with respect to x is equal to what? Is equal to 0. I come again. Maximum value of stress will occur when change in stress with respect to what? X is equal to 0. So I will write it down. Maximum value of what? Of stress, sigma all over 0. All right. So we are going to be differentiating what we have here. All right. So this will be the sigma all over what? All over the x equal to, all right, we have d all over the x of, this is of 60, all right, multiplied by 10 to the power of 4x all over what? All over root 2, 10 to the power of 4 all over root 2. Then we have x into 100 plus 10x close bracket minus 3. All right, don't forget to close your bracket. All right, now we'll be taking this as a constant. All right, I will be differentiating x into 100 plus 10x all to the power of minus 3. All right, so first we let k to be equal to 60 multiplied by 10 to the power of 4 all over the root of 2. All right, so we say let k be equal to 60 times 10 to the power of 4 all over the root of what? Of 2. All right, it means that d, it means that d sigma all over the x will be equals to, I have k, all right, multiplied by x into 100 plus 10x all to the power of minus 3. All right, so I am going to be using product rule to differentiate x into the bracket of 100 plus 10x close bracket all to the power of minus 3. All right, so that's what we are going to be doing here. Is nothing but what? Is nothing but d, all right, all over the x of uv equals to u prime v, all right, plus what? Plus uv prime. All right, now let u be equals to x. All right, let u be equals to x. So we say let u be equals to x, and let v be equal to the bracket of 100 plus 10x all to the power of minus 3. All right, if we differentiate u, we have u prime we're going to be substituting all our values into this formula. All right, so let's do that quickly. All right, so now we have d, we have we have d of what? Of uv all over what? All over the x to be equals to, our u prime is nothing but what? But 1. We have 1 multiplied by v. Our v is nothing but this. We have the bracket of 100 plus 10x, close bracket, all to the power of minus 3. All right, plus, what do we have? We have u. U is nothing but what? Minus. So this will be minus 3, all right, into 100 plus 10x, close bracket, all to the power of minus 4, all right, all to the power of minus 4 multiplied by 10, all right, multiply by 10. So we close the bracket and we have what? We have the this is u, this is u, all right, this is supposed to be x, this is supposed to be x. We have u prime, which is 1. We have v, which is this, all right, this is supposed to be u, which is x, all right, and it will be x multiplied by v prime, so we can just say multiply by x here. It's all. So this is what we have. So now we are going to be, don't forget I told you we are differentiating this part, taking k as constant. So we are going to be replacing what? The differential of what we have here into our equation back, all right. So if we replace that, we'll have the sigma all over the x will be equals to d, this will be equals to, we have k, all right, into, don't forget that k is multiplying everything, and the result of what we have there is what we have here. So we have 1 multiplied by this is 100, all right, plus 10x all to the power of minus 3, all right, plus we have minus, rather we have minus, so 10 multiplied by, this is minus 30x, this is minus 30x, all right, into 100 plus 10x, all right, all to the power of what? Minus 4. All right, don't forget to close your bracket. This is what we have. Now we have a value for k, don't forget. So we'll put our value for k back, all right. We are almost done, all right. So let's put the value for k and take note. All right, so please take note of this equation. We'll be making reference to this equation. When we get the value of x, don't forget we will substitute it here to get the maximum shear stress, all right. So take note of this equation because I'm going to clean it now. So take note of the equation. The sigma all over what? All over the x to be equals to, we have k to be equals to 60, all right, times 10 to power 4 all over square root of 2, all right. This will be into the bracket of, I have 100, right, I have 100 plus 10x, yes, 100 plus 10x all to the power of minus 3 minus 30x, all right, into 100, all right, plus 10x all to the power of minus 4, close the bracket. Now what I have here, all right, I can decide to divide here by 10 to the power, by 100 plus 10x, all right, 10 to the power of what? Of 6, all right. If I do that, I will have here to be 100 plus 10x to the power of what? Of 3, and here I will have 100 plus 10x to the power of what? Of 2, all right. Let's do that. So I can divide, all right. Let's do it here. So we have d, we have 60, all right, multiplied by 10 to the power of 4 all over the square root of what? Of 2, all right, into the bracket of what? Of 100, all right, plus 10x. This will be all to the power of what? All to the power of 3, because we are going to divide by what? 100 plus 10x all to the power of 6, all right. Take note of that. So we have minus 30x into 100 plus 10x, all right, close bracket. This will be all to the power of all over 100 plus 10x, all right, all to the power of 6, all right. So this is what we have. Now don't forget that changing, what is it called, changing sigma, which is changing stress with respect to x, is equals to what? Is 0. For what? For maximum bending stress to occur, all right. So that's what we have. Now from here we are going to equate this to 0, all right. Now this is a constant, all right. It does not have the variable we are looking for, all right. So we are not considering this, all right. Now we have the bracket of 100 plus 10x all to the power of 3 minus 30x into the bracket of 100 plus 10x all to the power of 2 all over what? All over this, all right. So if you equate it to 0, this, the numerator, will be equal to 0, all right. I hope you get that. You know that for a fraction, all right, we know that for a fraction to be equal to 0, the numerator must be equal to what? The numerator has to be equal to 0, all right. Or we can as well factor out the bracket of 100 plus 10x all to the power of 6 out, all right, and divide both sides by the coefficient of this bracket, all right. So don't forget that we have 0. The sigma all over the x is what? Is equal to 0. So we have 0 to be equals to, I have 60 multiplied by what? Multiplied by 10 to the power of 4 all over. I'm taking this one out. I have the square root of 2 into 100 plus what? Plus 10x all to the power of 6, all right, into the bracket of 100 plus 10x all to the power of 3 minus 30x close bracket. I have 100 plus 10x all to the power of 2, all right. So this is what I have. Now if I divide both sides by what? By 60 multiplied by 10 to the power of 4 all over the square root of 2 multiplied by the bracket of 100 plus 10x all to the power of 6, you realize that we have 0 all over this, all right. This will be gone. Should we do it? Let's do it one after the other, all right. We don't need to do that. Just know that when we divide both sides by this, all right, this will cancel, and 0 all over this will cancel. So we have 0 to be equal to what we have here, all right. So just divide both sides by this. You will get 0 to be equal to 100, that is the bracket of 100 plus 10x all to the power of 3 minus what? 30x close bracket. We have 100 plus 10x all to the power of what? Of 2. So all right, now we are going to factor out 100 plus 10x all to the power of 2 from both sides, all right, because it is common, all right. So 0 will be equal to 100 plus 10x, all right, all to the power of 2, all right. This will be into 100 plus 10x minus 30x, all right. All right, so this has to be in brackets, all right. All right, so now we are going to be dividing both sides by the bracket of 100 plus 10x all over 2, all right. If we divide both sides by the bracket of 100 plus 10x over 2, 100 plus 10x we go, we have 0 to be equals to what we have here. Take note of that, all right. So 0 will be equals to 100 plus 10x minus what? Minus 30x, all right. This is equal to 0 equal to 100, all right, minus 20x, all right. So this is the same thing as saying 20x is equals to what? Is equals to 100. If you divide 100 by 20, you have 5. So divide by 20, divide by what? By 20. It implies that x is equals to what? 5. X will be equals to 5 meters, all right. This is the value for x. Now recall that we have an equation for maximum bending moment. So we are going to substitute the value of x in that equation. So let me rewrite the equation here so that we'll substitute and get our answer. All right, so this is what we have as our equation, all right. Now we are going to substitute the value of what? Of x equals to 5 in this equation, all right. So our sigma max will be equals to 60 multiplied by 10 to the power of 4 multiplied by what? By 5 all over what? Square root of 2 into 100 plus 10 to the 10 multiplied by 5. 10 multiplied by 5 is nothing but 50. So we have 50 all to the power of 3, all right. So this is what we have, all right. So at this junction it is very, very simple and straightforward, all right. We are just going to calculate 60 multiplied by 10 to the power of 4 multiplied by 5, all right, all over the square root of 2 into 100 plus 50 all to the power of 3. All right, all to the power of 3. But you have to take note of something very, very important. All right, we are substituting 5 here, and 5 is in meters. All right, 5 is in meters, so we will have to convert meter to millimeter. How do we convert meter to millimeter? We divide by what? By 1000. But in this case, we can just multiply by 10 to the power of minus 3. All right, so multiply by 10 to the power of minus 3. All right, so if you do all of this, you have what? 0.628 newton per millimeter square, which is the unit for stress. All right, which is the unit for stress, newton per millimeter square. All right, so um our to bending sigma max will be equal to 0.628 newton per millimeter square. All right, so this is the final answer. All right, so I hope you understand what we have just done. If you don't understand, you can go over it again and see for yourself, or you can leave a comment on the comment section for clarification. All right, also to add to this, if you are in need of any of our materials, all right, we have well structured materials on all of our courses, well analyzed, well simplified, just for you. So kindly reach out to us for your own copy. Also, if you are in need of a private tutoring section, we also offer private tutoring sections, so you can reach out to us for yours. All right, and also to add, we are also open to collaborations, research, and what have you. So whatever you need in the field of engineering, be it mechanical, civil, electrical, reach out to us, and we'll be very sure to help you. All right, in the meantime, be sure to like, share, and subscribe. And if it is the first time you are coming across our channel, kindly give this video a thumbs up and click on the notification bell, so that whenever we drop a content, you will be notified. So thank you for watching. I will see you on the next one.